Hi. In this video, we're going to solve a fairly simple looking one-step equation here. And as we solve it, I'm going to really emphasize and try to explain a common error that people might make. So I hope that if you would have made that error too, you'll understand why not to make it and what to do instead. Okay, so the equation says 4 equals m subtract 3. Well, 4 is the same as m take away 3. So a lot of people, what they'll do, and I'm going to start with the wrong way first, is they'll look at this 3 over here and they'll say, well, I want to get rid of that. So first let's copy the equation here. 4 equals m subtract 3. And so what they'll say is I'm trying to get rid of 3. So what I'll do is I'll take away 3. So on each side, and they'll be careful and they'll do it on each side. They'll take away 3 and take away 3. So let's see if we can use some algebra tiles to help us explain why this doesn't work. What they're trying to do, of course, what they would then write is here, they'd say, well, we had 3 and we got rid of our 3. So they'd say, well, this is m and this is 1. So m equals 1, they think. So let's look at algebra tiles to understand what's going on here. We have 4. I'm using red as negative, which I made a little note of up here. So 4 positive is equal to m, so there's my variable. And take away 3, we can write this 4 equals m plus negative 3. Sometimes this makes it more clear. So these are equivalent here. M subtract 3 is the same as m plus negative 3. And that sometimes helps people figure out what to do with the algebra tiles, how to represent that there. So these two things are equal, 4 and m plus negative 3, or m take away 3. So what we did, the reason that this over here is wrong is if we're taking away 3, that's the same as, again, adding 3 negatives. So what that would look like, if we get our negatives ready to add over here and over here as well. So we add negative 3 to both sides. The reason that this didn't do what they thought it does is that over here we don't have 0. We don't have just m and 0 over here. We have m take away 6. So this is not right. What we would get is 1 equals m subtract 6. So if a person wrote this, they haven't actually done anything wrong. As long as they don't write just m here, if they know that that's m subtract 6, this is okay. The thing is that it's actually not helpful. So they've spent a while, sort of been a waste of time to do this work. It's got us to nothing. It's no easier than the original equation we had. So let's try a different way instead. I won't subtract 3 from each side. So we'll start in here we've got 4 equals, I'm just copying the equation, m subtract 3. And here's our representation with the algebra tiles. 4 equals m plus negative 3, so that's equivalent. So if we think, the algebra tiles can help us understand what went wrong there. Because we ended up with 6 reds, which is not equal to 0 at all. What we'd like is some 0 pairs. If we had 3 0 pairs here, that would be 0 and we could just get rid of it. So this, if we add positive 3 to both sides, and this is 0, that's 0, and that's 0. Let's write down what we're doing before we go on. So I'm going to copy the equation. 4 equals m subtract 3, and then we're going to add positive 3 to both sides. So over here, we do indeed have 7. And over here, because these are worth nothing, they're worth 0, we can get rid of them without changing the value here. So we get rid of our 0 pairs 1 by 1. So this has done what we were hoping for. We've isolated our variable here. m take away 3 plus 3 is m. So this up here, let's put this was false. And this here, we discussed, this is just not helpful. It's not helpful. This way here is correct. And when I don't have much space left on the paper, so maybe we'll do this out loud. We'll do a check here. If we substitute 7 for m, because we've said that they're the same, our question is 4 the same as 7 take away 3? 7 take away 3, yeah, that's 4. 4 is equal to 4. So that means our solution here is correct. Alright, so the takeaway here is that if you have an equation where you're subtracting in it and you're trying to isolate a variable, pay real close attention to this sign and think things through to make sure that the operation you're doing does in fact sort of get rid of what you're hoping to get rid of here. Here, if we subtract 3 and we subtract another 3, that doesn't get rid of it. We're not down to 0 now. We're down into minus 6, negative 6. But if we are subtracting 3 and then we add 3 on, if we do the opposite operation, then that gets, all of that is equal to 0, which is what we were hoping for. All right, good luck. Thanks.